This is just one that is a great example of what we typically see for an indoor facility that runs all their flower rooms at the same time, which we just kind of refer to as concurrent operation. So you can probably understand what's going on here. Their lights turn on at, right about, what is this, 7 a.m., 8 a.m., 7:30. So you get this big jump in demand as all of the lights, all the flower lights come on in this facility, and all the HVAC equipment spins up to deal with that demand, the sensible loads and the latent loads that are going to start creeping in. As the day progresses, we always, not always, but we typically see this dip as the HVAC system starts to slow down a bit. And then finally, towards the end of the typical 12-hour photo period, we see a sharp drop off as all the flower lights go off and the HVAC systems spin down accordingly. You'll notice there's a little bit of a difference here between that flower on period and the flower off period. That's generally associated with the different photo period of the veg lights, which are much less intense, but nonetheless do show themselves in these daily load profiles. So this is about the peakiest way that you can operate an indoor cultivation facility. By having all of your lights come on at once, it creates this really big demand. So what might that look like if we were to run a facility with balanced flower rooms? So this is a different facility, but they run half their flower rooms on, half their flower rooms off. They have an odd number of flower rooms, so this isn't an exact 50-50 split, but you get the idea. And you can see right away, it's a much flatter load shape. There's a little bit of a peak here. This is when the second batch of flower rooms comes on. Again, it's a little bit of a larger collection of rooms, a much flatter period. This is very beneficial for a number of reasons. It's going to bring down your overall demand. It creates a much flatter load profile. It creates opportunities to right size your HVAC system. And if you're looking at all at any sort of combined heat and power, this is the kind of load shape that you're looking for to optimize the use, the efficiency of combined heat and power systems. Take a look at the next one. So what does this look like? If you have a facility that's running all concurrent flower rooms, we've looked at that. And if we take that facility and essentially model it to run split flower rooms or balanced flower rooms, this is the sort of drop that you're looking at just by changing the schedule of your facility. Easier said than done, because if you run 12 on, 12 off, and the other half 12 on, 12 off, that pretty much necessitates an overnight crew. So there could be additional labor costs there. I have worked with facilities that run balanced flower rooms that don't have an overnight crew. They have, sensors within the space with alarms. If anything goes wrong, somebody's on the schedule to haul butt over to the facility and see what's going on. But this is a really big, probably the single largest opportunity for cultivation facilities to reduce their demand.